Hello, folks. One second. Is that better? Okay. Now folks can hear me. Hi, folks. Welcome to Advent of Code. This is day number 17. And I have a special treat for you, which is that my computer, I took it down for upgrades, and it did not come back up. But fortunately, I have not one, not two, but three backup options prepared, just in case the first option didn't work. So we're going to put that to good use today. So let me share with you the workstation I'm working from. So this is a Ubuntu 2004 workstation. It's running the 5.8 kernel, and it is not an AMD 64 processor, so it's neither Intel nor AMD. It's a ARM Holdings processor, and specifically it is a Cortex A72 processor. And I have a Radeon graphics card in here. It's got 32 gigs of RAM. And as you can see, it streams pretty flawlessly. Let me just check on the chat to make sure that that statement is actually true, but I believe that it streams pretty flawlessly. I'm pretty proud of it, and I had to do a little bit of wrangling right before the stream to get the screen sharing to work, but I think that is working now. And as you can see, if I run yesterday's solution, it just works. My nano config still is the exact same because I synchronize my configs between my workstations. So yeah, that is what the deal is with my ARM64 machine. It is no longer quite as novel to have ARM64 on the desktop. It used to be that almost no one had them, but now people have M1 Macs, which are ARM64 on the desktop as well. But this is Linux ARM64 on the desktop, which is a particularly novel brand of masochism. Day 16's Advent of Code website is frozen at 4:28. Oh, let me fix that real fast. Thank you for telling me. Remove, add, desktop screencast, share that window. There, is that live updating now? Sorry about that. As I was saying, I'll keep an eye on it just in case. But as you can see, it runs Go just fine. It runs Nano just fine. That just works. Oh no, this is disappointing. My OBS thinks it's transmitting. Can anyone else see video? See video of me. Okay, so you see video of me. Now try that. How do I get OBS to automatically switch when I pull up a view? That is potentially a problem. Switch to scene. Oh, I see. I have to hit. Oh dear, I don't have a pause key. Why does OBS just not automatically switch video between scenes? We're just going to use insert. Okay. Try that. Wait. Does that not work? I'm not in the. Oh, there's no video of me in the corner. Got it. Oh, sorry about that. I did not understand. So my video is working correctly. I just needed to do that. There. Is that better? Does that do what people expect it to? Great. Oh, now it's stuck. Well, I guess we're going to get started, and I will fiddle with this again, and read the problem at the same time. This is wonderful. This is perfectly fine, I swear. There is absolutely nothing going wrong here whatsoever. Order move to bottom. Okay. Now is that working? Oh, people are saying, hello, 60 FPS, yeah. Okay, hopefully this stays working for the rest of the stream. Now let's actually solve the problem. So this is day 17. All right, inputs, day 17, input. In fact, we can, oh, this is some kind of a state machine. Okay, get my puzzle input. All right, this feels like if I hadn't had graphical issues, it would be pretty straightforward. Let's see, which one had the chairs? Okay, we're going to copy my day 11 solution to day 17, and we'll work with that, because I think this is the closest match to what we have so far. Wonderful. All right, so except for, instead of it being two-dimensional, it's three-dimensional. So we're going to have x, y, z instead. All right. And let's see. So cubes start inactive. Each considers its neighbors. Yep. All cubes simultaneously change their state. Exactly. Yep. Okay. I understand. This is perfect. So my initial input is simulating 6 cycles. What is my first input, though? Oh, my first input is always z equals 0, right? Okay. Yep, that's correct. Fair enough. Okay, so I understand this. So actually, all of this code works pretty much the same, except we're going to delete the code from last time, and we're going to change r offset to x offset. We're going to change c offset to y offset. All right, and we're going to change row to x. We're going to change col to y. All right. Great. So I'm not going to memoize to start with. I'm just going to do this. So we're going to z offset is 0, and we continue. So now we just embed this one layer deeper. All right. Okay. And that all should work, with the caveat that we need z plus z offset. Okay, that seems pretty good. All right, now that all is totally reasonable, except for I need to do chord to chord 3. Ah, okay. I'll go fix that other one. Wonderful. Okay, now let us read in the input. So the input is still correct. And in fact, but instead here we have, this is the y's. Let me just check this. So I guess it doesn't matter as long as it's self-consistent what's a y and what's an x. We're going to do this. That way I have kind of a coordinate plane. That is straightforward. Okay. So if it is a hash, then it's active. Otherwise, it's not active to start with. If a cube is inactive, but exactly 3 of its neighbors are active, the cube becomes active. Okay. So the problem is I need to consider any cube that is adjacent to any existing cube as being part of the set of things that I simulate and consider. Okay, so all right, we'll just fix that up and fix that up as well. Okay. Now, what do we have here? Chord 3 of x, y is true, and then 0. Okay, so now we can proceed. So we still have the previous state, that's good. So we want to... Why was I copying the previous state? Oh, because otherwise you wouldn't mutate it in place. Okay, that's correct. All right. So if it's active, and there are exactly 2 or 3 neighbors, it remains active. I don't want to recompute this twice, that would be silly. So if neither of those two things are true, then we wind up deleting from active the current coordinate. Okay. We know by definition all of these are active, but the problem is I don't just need to iterate on all of the actives. We need to also find all of the neighbors and add those to prev as well. Because otherwise we're not going to test things that don't exist in our map yet. So we're going to do that in a second. So K adjacent. Wait, why does this need the active map? Oh, it doesn't. It would need it for the part B solution of the last time around. But in this case, we don't have the constraint yet to look at multiple further away ones. Hi, where is X? How are you doing? Okay, cool. All right, so we return a list of adjacents. So first, right. All right. So we will not overwrite an existing value, but if I do see a value that is set to true, I will populate all of its three-dimensional neighbors to have the false value. Okay. Okay, I'm happy enough with that. So now we won't double add as well, which is convenient. Okay. So now this else case makes sense. So if the... that does actually need to take... Okay. Yep. So if active n, then count of adjacent neighbors is correct. Okay, that's fine now. All right, I believe this. So if there are exactly 3 of its neighbors that are active, then it becomes active now, and we've changed it. Okay. And it's asking us the simple question, how many cubes are in the active state? So we're not looking for it to terminate, we're just looking for it to iterate 6 times. One, 3 cycles, after 6 cycles, okay. Line 65, missing a range. Okay, let's run it on the sample input first. So the simple input is this one. Change declared but not used. Line 62. Oh, yeah, I don't need the changed anymore. Okay. And I get 155, which is incorrect. Okay, so now we need to do a little bit of debugging. So let's take the debug flag as well. So we have a debug flag we can just swipe. So I don't like typing a lot of stuff over and over. Okay. So how are we going to do this? Well, let's see. That feels fine. Yeah, that should be okay. Is my active neighbors correct? All right. Let's print out the number of active nodes at each step to see where I'm going wrong. It's probably something super simple. Okay, so at the first step, after running 1 cycle, am I running too many cycles? One, two, 3, 4, 5, 6. No, that's correct. Okay. All right. So let's have a look at this. So we have 0, 1, -1. Wait, is the... Three by 3 by 1. It doesn't really matter where your 0 is set. That's fine. Okay. So in my -1 layer, I have the coordinate x of 0, y of 1. Yeah, that's correct. Let's also... Okay, let's do the simpler thing here as well. Okay, so there should be 8 values. Oh, okay, that's clearly wrong. So after 1 cycle, my code thinks that there are 8 nodes set, when in fact there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 nodes that ought to be set. Okay, so I've got a simple logic bug. Consider each of the neighbors, the 27 ones, yep, where it differs by 1. Any of their coordinates differ by at most one. Yeah, that's correct. If the cube is active, and exactly 2 or 3 of its neighbors are also active, then it remains active. So the cube is active, and 2 or 3 of its neighbors are still active, then we stay active. We don't modify the active set. Otherwise, it becomes inactive. Yep. All right, and over here, if it's already inactive, it stays inactive unless exactly 3 of its neighbors are active. Okay, that feels okay. Why am I waist deep in debug output? Because my code doesn't work, Eric. That's why it doesn't work. So let's make sure that I just parsed the input correctly to begin with. So, all right. Check your assumptions. I am checking my assumptions. Oh, okay. Yeah, the hash means active, the dot means inactive. That's correct. Just verify this. Gives me plenty of time to think on my mistakes. Okay. Oops. That should be chord 3 down here. What? Oh. This should be that kind of octothorpe. Okay. So that is the correct output. Great. Let's just really quickly, at the top of this, at the start of each cycle, I'm going to print out what this looks like for each of the... I'm just interested in the first case for now. All right. Okay, let's test that real fast. Okay, so we start with that. That looks fine. Wait, why is this happening twice? Oh, wait. I see the problem. Why is it having Z... Why is Z set for all of them? That should not be the case. Active is a map from chord 3 to bool. We've got X, Y, and Z coordinates. Hey VWoo, I am having some computer troubles today, and also I am having some reading code troubles today, apparently. X, Y, Z, let's just fix this while I'm here. Don't have any obvious mistakes here. All right. So yeah, that is real fascinating. Yeah, okay, that's my bug, is that for some reason the Z coordinate is set 3 times when it shouldn't be. So I think that's my problem. But this is set correctly here. Oh, I see. Oh, my reporting code is just as a bug. This needs to say Z here. Oh, I feel bad. Okay, so now it looks correct. But over here, this one is now wrong. Okay, I understand how to work with that. Yeah, I'm aware that I'm pretty sure that I have a very small bug, so I'm not worried about optimizing the view frame. I'm just literally like trying to understand what's wrong with this code here. Oh, wait. Active neighbors of previous. Yeah, that's fine. So is my active neighbors still working correct? Boo, Chick-fil-A. Fuck homophobes. Okay, that should still be fine. Let me just do a quick check here. Oh, is this my problem here? No, previous of n, range k adjacent. That's fine. Okay, let's make sure that my adjacency is correct. But my adjacency does look correct. That's fine. Hey, Pixely Squid. Yeah, this problem's giving me unusually much trouble. I feel like I have the correct algorithm. Let me see this. So let's try this real fast. Okay, so my initial set had 5 active things, that's correct. In the end, what I should consider, I should be considering every value above, below, and to the sides. So that should include both the initial 5 as well as everything to the sides here, and then everything top and bottom. So that's going to be 6 here. In fact, yeah, no, we do have to consider all of these. Okay. You know what? Let me, I can just print this. That's fine. I'm running out of ideas here, but I'm going to figure out what's broken with this come high or hell water. Oh. Right. Okay, we know my initial input is now correct, so let's just do this. Okay. Where else do I have a print that I should... Yeah, okay, I'm confident my initial set is correct now. Okay, I see one obvious problem here, which is in that first set here, I should have considered, yeah, I'm not considering enough values for some reason. I should be considering the value at this value right here. Oops, the highlighting is broken. I should be considering this value right here, because it says, yeah, the 26 things, which is 9, going to be 9 below, 9 above, and 8 around. That's 26. Yeah, so I'm failing to consider this one. This one here has a neighbor that is 1 above, 1 to the left, and on same row, and it's not considering it. So, oh wait, no, actually that's not correct. Let's try this. Okay. So yeah, so now I am correctly considering all of these. And yet, for each of the things that was considered, it doesn't match up with the value we should expect to see after one cycle. Yeah, okay. So I think I see one of my problems. Let me just expand this out so I see this more fully. Okay. Wait. This looks like now like this might be correct. That this viewport frame... Oh, that's why Eric meant that it was... that the viewport frame is shifting. Because I can see that pattern. I'm just not reproducing... Hey, Anthony. Oh my goodness. I feel like I am really struggling here, so I'm glad that you are sending help my way. So the problem here, as I understand, is... Oh, I should probably change this to say after iteration 0. So I start with 5 nodes active here. And I should wind up with 6... 11 nodes active, but my rule is wrong. Yes, Sino is up. Good call, good call. Wait a second. Okay. Yeah, that feels correct. Let me just do something real stupid. You know that you're at a good state in your debugging when you're doing things like this should never happen. Yeah, assert false and reachable. I love it. Okay, so no, the problem is not that my coordinate list is bad, at least as far as I can tell. All right. So if my coordinate list is not bad, I'm really going to need to resort to printing out each active neighbor. Okay, fine. We're doing this. Guess we're doing this, aren't we? Okay. Fine. What's the Boolean? Boolean is %t. Great. I really detest that I'm doing this. Okay, we're actually doing this, aren't we? All right, are all of these in fact off by a factor of 1? Yes, I have 26 entries that are all off by a factor of 1. Okay, test number 2. Am I at any point? I should be evaluating the point. I should be evaluating the point x is 1, or x is 0, y is 0, and z is 0. That should get evaluated at some point. Does it? And it has. Okay, there is a problem. 0, 0, 0 ought to have 1, 2, 3, 4, 5 neighbors that are all active. But yet, for some reason, we're failing to detect those as active. Yeah, okay, I see my problem. I'm instantiating... Did I get too clever here? Or I just got too clever. For each thing... Okay, why, though? This does not make sense. So the neighbors of 0, 0, 0... So for some reason my code thinks the value at 0, 0, 0 is false, which it is. Okay. If it's inactive and exactly 3 of its neighbors are active, then it becomes active. So here, after one cycle, why does this one become active? Previously, it was off and it had 5 neighbors that were active. Eric, I don't understand your example. Because 0, 0, 0 here becomes active somehow, and yet this does not have three neighbors that are active. Oh, that's ridiculous annoying. Okay, so once we get past that malarkey, if we move past that malarkey, then I can reproduce the results here, right? Like, I do see that pattern here. But what I don't see is that pattern on the middle layer, and that's where I'm going wrong somehow. You know what? When in doubt, expand the reference frame. We're doing it. All right. So A9 said the middle cell in Z0, T0. So you're saying, A9, you're saying this cell here is the same cell as this cell here. Is that correct? Yes. Wait. The cube is inactive and exactly 3. Wait, okay, so this cell here becomes this cell here. Okay, so that helps me understand. So then this cell here then is this cell here. Yep, so I believe that one should turn off. This cell here has 3 active, so it remains on. Okay, and then this cell here is this cell here. So those two. So this one has 3 active neighbors. Okay, now I understand. Great. Okay, now this helps me understand what's fucked. Okay, so I am looking to debug why I am not getting the expected middle row here to start with. I should expect to see 2 cells here set to true, which means there's something wrong with my exactly 2 or 3 of its neighbors are also active. It remains active. Okay. Exactly 2. Oh. God damn it. That, right there. That was my problem. That was my problem. Yeah, okay, now that's 112. Okay, now I run it on my full input. Fuck that. Okay, that's correct. That was... I am so mad at myself now. So my problem was I was looking for if active neighbors is equal to 2 or active neighbors is equal to 3, then do not delete. And then I transformed it. I did not change the or to an and. The Boolean logic of inverting an or, right? If you invert an or, it becomes a nested and. Fuck. Okay. Okay, it has 4 different dimensions. All right, that's fine. All right, this is really simple enough. Okay, we're going to fix this, and we're also going to get rid of all of our debugs because I no longer need them. I understand exactly where this was going wrong. If the coordinates had matched, I would have been able to debug this much faster, and I would have been able to figure out which nodes were supposed to line up with which nodes they were supposed to be on. But because I was unable to do that, I just, I flubbed it. Okay, just make sure that still works. 202, great, okay. I'm just going to check that in real fast. That way, if I do need to revert, I can. Dimensions is 3. If part B, then dimensions gets changed to 4. Yeah. Okay. You know what? Actually, I'm just going to transform this all to 40 coordinates and make the part A, part B just okay. Okay. X, W, X, Y, Z. Okay. All right. All right. How do I want to condition this? W offset. Okay. Actually, we'll do it this. No, we got to do it this way. Okay. All right. Right, we're getting there. If W offset is not equal to 0 and not part B, let's make sure that we get these correct. And now for the rest of Advent of Code and probably another couple months after this, I'm going to be checking my De Morgan's Law every single freaking time. Okay, So if W offset is not equal to 0, and we're not in part B, then we continue. All right, that should do it. Okay, that's all the same. And this is just always now WXY. Okay, that logic is still exactly the same. Four-dimensional hypercube considers only its neighbors. Okay, so this is familiar enough. That makes sense. De Morgan's law is when you try to multiply out a exclamation mark on a Boolean expression. So not A or B becomes not A and not B. Okay. I feel like I understand how to do this. Okay, so this still returns 202. Great. So is this literally as simple as running it with part B? All right, well, let's run it on the simple input. Do I get 848? Yes, I do. Oh, that was so easy. Oh, I feel so bad. Okay, so the answer is 2028. And that's correct, and I'm done, and I literally would have finished 40 minutes ago if I hadn't gotten hung up on that one De Morgan's Law thing. Okay. So... oh, I feel so bad. Feel so bad. Okay. The only change that I needed to make for part B was I literally just needed to change this to account for an additional dimension and to say don't consider things that are adjacent in the W dimension if I'm in part B. Otherwise, do consider it part of part B, or do consider the fourth dimension. Yeah. That's literally the only change that I had to make. Everything else was exactly the same. All of this code here that was trying to accumulate what the list of possible neighbors was that possibly could be next to at least one cube and therefore should be evaluated for adjacency to 2 or 3 cubes. That was already done. So, yeah. Sucks to be me, I guess. I guess one optimization I could have made is here. When I'm calculating the adjacency, the thing I probably should have done is just kept a map and just incremented to get the count of nodes adjacent to each other node. So in fact, why don't we really quickly do this? Because I think this will clean up the code a little bit. My belief is, let me check this in first. Oh no. How do I change the email? Because this is a new computer that I newly have set up. Okay, so... All right, is this correct? Yep, that looks correct. All right, so now we've pushed it up. So I would like to, Viwu has a suggestion on how to make that faster. So I would like to, instead of doing this process here, because this avoids tedious recomputation, which I kind of like. If a node is off by itself, though... Okay, this still needs... because a node does not neighbor itself. All right. By the way, I'm just curious to see. Okay, we're mid-flight to yet another island. Grumble, grumble. Okay, now I see we're filling in missing entries. All right, so now I believe that this becomes simple enough. Because this now can be retrieved from the cache. I no longer need to recompute it. Instead, I can just ask. Oh, I need an inline type here. You know what? Okay. All right, so I think that this should... I think that this code is a little bit tidier because it avoids needing to double pass. Or more, like, it avoids needing to recompute number of neighbors repeatedly, which I like a little bit more. Right. All right, does this still work? Let's find out. And line 70. Oh, this is just K. Okay, yep, that works. This also works. It's a little bit faster. All right, with that, I'm going to go ahead and end my stream. Thank you all for tuning in. You can find my code, github.com/LizTheGray/admin of code. Also, for those of you who didn't see earlier, this is running on ARM64 on the desktop. So this is a ARM Cortex 7216 processors. It's a pretty fun box. Awesome. I will catch you all tomorrow. I will find someone to raid, I'm sure. Nope, no one else is running. I'm the last one running. Cool. See y'all later.